Let us speak of a world where knowledge was an unshakable fortress, a fortress built not on what one saw, but on what was known by tradition, by ancient books, by unquestionable authorities. In this world, the earth was the center of everything, and the heavens, a perfect sphere, immutable and untouchable, where stars and planets revolved in divine orbits. To question this was not just an intellectual challenge, it was heresy. But then, a man emerged, a man with an insatiable curiosity and a simple yet powerful tool that would turn this world upside down. He did not accept what he was told, he wanted to see. And by seeing, he revealed truths that would forever transform humanity's relationship with the universe. This is the story of Galileo Galilei, the man who dared to look at the sky and changed our way of seeing the earth. In the city of Pisa, in 1564, the year of Michelangelo's death and Shakespeare's birth, Galileo Galilei came into the world. The son of Vincenzo Galilei, a talented musician and music theorist, and Giulia Amanati Galileo was born into a family of the lower nobility. His father was a man ahead of his time, who valued experimentation over pure theoretical authority. Vincenzo challenged the established musical rules of his era, preferring to test ideas based on experience. This seeing is believing mentality was a crucial legacy for the young Galileo. From an early age, Galileo demonstrated a brilliant intellect and a passion for creating and understanding how things worked. He was skilled with his hands, building mechanical models and drawing. His parents, seeing their son's talent, initially encouraged him to pursue medicine, a lucrative profession at the time. Thus, at the age of 17, Galileo enrolled at the University of Pisa. However, the study of medicine did not captivate him. Instead, he found himself increasingly drawn to mathematics and physics. He discovered Euclid and Archimedes, and the studies of natural phenomena fascinated him more than medical treatises. Even as a student, Galileo already showed his questioning spirit. The best-known story is that of his experiments with pendulums. It is said that one day, while attending Mass in the Cathedral of Pisa, he noticed a chandelier swinging. Using his pulse to measure the time, he realized that the period of the oscillations was constant, regardless of the amplitude. This challenged the Aristotelian notions of motion and paved the way for understanding the isochronism of the pendulum, which would later be fundamental to the creation of more accurate clocks. Another famous myth, though historically debated, is that Galileo climbed the Leaning Tower of Pisa to drop objects of different masses, proving that they fell at the same speed, contradicting Aristotle, who claimed that heavier objects fell faster. Although the story is likely apocryphal, it perfectly illustrates Galileo's method to challenge authority through observation and experimentation. His mind was not content with what was written in books. He needed to see, to test, to prove. This temperament soon put him at odds with the conservative academics of his time, many of whom were staunch defenders of Aristotelian thought, which dominated the universities. Galileo's personality was not an easy one. He was argumentative, confident in his abilities, and did not hesitate to express his opinions, even if it made him unpopular. These characteristics, combined with his genius, secured him positions as a professor of mathematics in Pisa and, later, in Padua. During this period, he carried out important work in mechanics and astronomy, but he had not yet made the discoveries that would make him immortal. The great turning point came with an invention that was not originally his. In the early 17th century, rumors of a Dutch spyglass, an instrument that made distant objects visible as if they were nearby, began to circulate through Europe. Although Hans Lippershey is often credited with the original invention in 1608, Galileo, upon hearing the description, was not content to wait for a commercial version. Using his knowledge of optics and his manual skills, he quickly built his own model, without ever having seen the original. He improved upon the initial design, increasing the magnification power from 3 times to 9 times, and then to 20 or even 30 times. He had transformed a curious toy into an unprecedented scientific tool. First, Galileo demonstrated his perspicillum, as he called it, to the rulers of Venice, showing its value for navigation and military observation. His invention earned him a salary increase and a lifetime teaching contract. But Galileo's mind had a greater purpose. He was not satisfied with pointing the telescope at distant ships or enemy towers. He knew that the true potential of that instrument lay elsewhere. He would point it at the oldest and most mysterious of objects, the sky, and what he would see up there would forever change humanity's understanding of its place in the universe. With his improved telescope, Galileo did not hesitate. He pointed it at the sky, seeking to answer questions that had afflicted humanity for millennia. His observations would be a devastating blow against the Ptolemaic Aristotelian geocentric model, which placed the Earth at the center of a universe of perfect spheres. The first revelation came from the moon. Contradicting the belief that celestial bodies were immaculate spheres, Galileo saw mountains and craters, valleys and shadows. The moon was not a perfect orb, but a world with imperfections, surprisingly similar to Earth. This observation was crucial, as it broke the artificial distinction between celestial perfection and terrestrial imperfection. Then came the stars. Galileo's telescope revealed that the Milky Way, the Milky Band in the sky, was not a gaseous cloud. but a myriad of individual stars, too numerous to be seen with the naked eye. This expanded the scale of the universe in an unimaginable way, making the geocentric model even more unlikely. In 1610, Galileo made his most revolutionary discovery. While observing Jupiter, he noticed 3 small stars aligned near the planet. Subsequent nights revealed that these points were not fixed, but moved in relation to Jupiter. Soon he identified satellites, now known as the Galilean moons, orbiting the gas giant. The implication was profound. Here was a miniature system where celestial bodies orbited another planet, and not the Earth. This observation provided convincing visual proof that not everything revolved around our planet, eroding the foundation of geocentrism. His observations extended to Venus. Through the telescope, Galileo noticed that Venus exhibited phases, like the moon. Sometimes it was a thin crescent, other times an almost full disk. This observation was only possible if Venus orbited the Sun, receiving light from different angles in its trajectory. If Venus orbited the Earth, as the Ptolemaic model suggested, its phases would be inconsistent with what he saw. The phases of Venus were, therefore, irrefutable proof of Copernicus's heliocentric model. Galileo also observed dark spots on the Sun, sunspots. He noticed that they moved, indicating that the Sun rotated on its own axis and, more importantly, that its surface was not immutable and perfect, as Aristotelian doctrine dictated. Even the star king, the symbol of divine perfection, had its imperfections. In March of 1610, Galileo published his discoveries in the book Sidereus Nuncius, the Starry Messenger, written in Latin for the academic audience. The book caused a shock throughout Europe. These were not abstract theories, but concrete observations, accessible to anyone with a telescope. Suddenly, the universe was no longer as it was thought to be. Galileo's book validated the heliocentric model of Copernicus, which had been proposed 70 years earlier but lacked direct observational proof. These discoveries were the seed of a scientific revolution, but they also planted the seeds of an inevitable conflict with the most powerful institutions of his time. The Catholic Church. Galileo's discoveries, though based on observation, came into direct collision with the literal interpretation of the scriptures and the doctrine of the Catholic Church, which firmly defended the Ptolemaic geocentric model. Psalm 104, for example, stated that the earth shall never be moved, and Joshua 10:13 described the sun standing still in the sky, implying that it normally moved. For the Church, these passages were proof that the earth was the immovable center of the universe. Initially, the Church reacted with caution. The first warnings were not directed at Galileo, but at the Copernican theory. In 1616, the Holy Office declared that the idea of a stationary sun at the center of the universe was formally heretical. Galileo was summoned and warned not to defend or hold the Copernican theory. He was allowed to discuss it as a mathematical hypothesis, but not as a physical truth. Galileo, a devout Catholic, argued that the Bible was not a science manual. The intention of the Holy Spirit, he said, is to teach us how one goes to heaven, not how heaven goes. He tried to reconcile faith and reason, but the Church saw any challenge to its interpretive authority as a threat. Despite the warning, Galileo remained hopeful. In 1623, his friend and admirer, Cardinal Maffeo Barberini, was elected Pope Urban VIII. Galileo traveled to Rome to greet him and obtained permission from the new Pope to write a book discussing the cosmological systems, provided that he presented both sides impartially and treated Copernicanism only as a hypothesis. The condition was clear: he should not openly defend the theory. Confident in Urban VIII's benevolence, Galileo spent years working on his masterpiece. In 1632, he published the dialogue concerning the two chief world systems. The book was a conversation between 3 characters: Salviati, a defender of Copernicus; Sagrado, an impartial observer; and Simplicio, an Aristotelian who defended geocentrism. The dialogue was written in Italian, not Latin, to reach a wider audience, which was already a bold act. Despite his promise to the Pope, the book was a thinly veiled defense of Copernicanism. The character, Simplicio, who defended the geocentric model, was portrayed as a simpleton, naive and sometimes foolish, frequently refuted by the other two. Worse, Galileo put some of Pope Urban VIII's own words into Simplicio's mouth. The Pope felt ridiculed and betrayed. His friendship with Galileo crumbled, and his fury was relentless. Galileo was immediately summoned to Rome to face the Inquisition. It was 1633, and he, already an old and sick man, traveled under duress. The trial was brutal, under threat of torture, though not directly applied, and facing immense pressure, Galileo was forced to abjure his heliocentric beliefs. He read a formal recantation declaring that he renounced and cursed his errors and heresies. The story goes that, after the abjuration, he muttered the famous phrase, "Eper si muove," and yet it moves, referring to the earth. Although the story is apocryphal, it encapsulates the spirit of a man who, even under duress, knew the truth of what he had seen. Galileo was convicted of vehement suspicion of heresy and sentenced to prison. His sentence was quickly commuted to house arrest for the rest of his life. The man who had dared to reveal the secrets of the universe was now silenced and confined, a stern warning to anyone who dared to challenge established dogma. The Church had won the battle, but the war for the truth was just beginning. After the humiliating trial and forced abjuration, Galileo was sentenced to house arrest for the rest of his life. He spent his final years in his villa in Arcetri near Florence, under constant surveillance by the Inquisition. It was an isolated and melancholic existence, marked by illness and, eventually, by blindness. The irony was cruel. The man who had revealed the deepest secrets of the cosmos, who had opened the heavens to humanity, was now unable to see them. However, even in his captivity and with failing vision, the flame of his curiosity and intellect never went out. During these years of reclusion, Galileo secretly worked on his most important work on terrestrial physics. His focus shifted from the macrocosm of the heavens to the microcosm of mechanics, motion, and the resistance of materials. The result was the book Discourses and Mathematical Demonstrations Relating to Two New Sciences, often shortened to Two New Sciences. This work, published secretly in the Netherlands in 1638, would be the foundation of modern physics. In Two New Sciences, Galileo revisited his early experiments and thoughts on falling bodies, the trajectory of projectiles, and the strength of materials. He formulated principles that would later be refined by Isaac Newton. His experimental and mathematical approach to understanding nature solidified the scientific method. He demonstrated that the speed of falling bodies does not depend on their mass, disregarding air resistance, and that the trajectory of a projectile is parabolic. These were universal truths, proven by mathematics and observation, not by dogmas or ancient authorities. Even blind and under the shadow of the Inquisition, Galileo was paving the way for the future of science. Galileo Galilei died on January 8, 1642, at the age of 77. The church which had condemned him refused a public funeral and the construction of a monument in his honor. He was buried in a modest spot in the Basilica of Santa Croce in Florence, far from the great names. However, time reversed this imposed silence. Ironically, in the same year of his death, Isaac Newton was born in England. Newton, upon whose shoulders science would rise, would build his laws of universal gravitation and motion on the foundations laid by Galileo. Galileo's legacy is immense and multifaceted. He not only gave us the telescope and celestial discoveries, he gave us science as we know it. His insistence on empirical observation and mathematical measurement, rather than authority, was a methodological revolution. He taught humanity to trust its own eyes and its own reason to understand the universe. The separation between science and religion that he inadvertently initiated, though painful for him, paved the way for the autonomy of scientific thought. For centuries, Galileo remained a symbol of the conflict between science and dogma. Only in 1992, more than 350 years after his death, did the Catholic Church, under Pope John Paul II, formally acknowledge the error of his condemnation, rehabilitating Galileo. It was a late, but significant, recognition of the truth he had defended with such passion and suffering. The story of Galileo Galilei is the story of a man who, armed only with curiosity and a piece of glass, dared to challenge an entire world. He showed us that the universe is not a static stage for humanity, but a vast and dynamic laboratory. His life is a reminder of the power of observation, experimentation, and the tireless search for truth, even in the face of the most severe adversity. The universe, for Galileo, was a book written in the language of mathematics, and he was one of the first and most courageous to read it. What surprised you most about the story of Galileo Galilei? Which of Galileo's discoveries do you consider the most impactful for the advancement of science? What other historical figure in science would you like us to explore in our next documentary? Let us know in the comments, as the next adventure begins with you.